Hello and good morning. Today we're going to be touching on foundations and a brief description on scheduling the bars. So let's go ahead and open our AMT Revit file. There's our building we did before. Now, if you haven't done this, don't worry. Just draw in a wall for now. And if you don't know how to draw in a wall, then go back a step and have a look at my previous tutorials. So what we're going to do, we're going to put a strip footing on these walls. Okay. Now, before we made them minus 450 below ground floor level, which is going to be to the top of our concrete foundation. Right, if I go to any elevation, let's go to this one. Make it 1 to 50, or make sure it's still on 1 to 50, make it fine. Click on one of the levels in the bluey purpley dot, click and hold and drag so it's out a little bit. We're going to go ahead and create our foundation level. So if we click once on 00GF, or your finished floor level at ground floor, click the copy, click once and hold and drag down and just type in 450, and there we have it. Now if you come against this scenario where your annotation clashes, if you click once on the level and you see a little zigzag, click the zigzag and it does this sort of shape. You can then drag the blue dots however you feel then, so it gets away from the annotation and doesn't clash. We'll leave it there for now. What we'll do, just lock that in. There we are. Right. We also notice that we've created a new level, but it's not in our floor plans. So we'll, as before, we'll go to View, Plan Views, Floor Plan, and you can see it's sitting there ready to go into our project browser. Just click OK. And there it is. Let's go ahead and rename it as well. And we'll rename it -01 dash foundation FL for foundation level. Yes, there it is, and there it is. Keep it all nice and orderly. Okay, if we go into the view now, we'll notice that it's not quite on the foundations, and the foundations actually can't be seen. So what we'll do is we'll just make the view range change. So in the properties of the view, go to view range and edit, and you notice now it's at the cut plane and the view range is too high, so you wouldn't be able to see anything at foundation level. What we just want to see a wall just above the foundation, and then we want to see the whole foundation. So if we make that 100 and this one 100, that then we'll see 100 millimeters above the foundation or the level -01 dash FL. And we also want to see below it. Now we could just make it unlimited, that's fine, but we just want to see the foundation for now. And our foundation is going to be maybe 300 deep, maybe 450, we'll see now. So let's go ahead and make that -600 and make the bottom one -600 as well. Just click OK. No, so those are our walls that are sitting 100 above, and the reason we kept them in is because we want to see how the wall sits on the foundation, but we don't want to see the doors or windows or anything like that, and that's what this will show. So go ahead and click on 3D. Everything should be set up now to put in a foundation, and we can see it on our level. So if we go to Structure, and you got this foundation tabs up here. You got Isolated, which is for like columns. You got a slab, which we'll draw a normal slab like you see here, but it'll be a structural slab. And then we got the foundation by wall. That's the one we're going to use now. So we're going to click on this, and it's just our wall foundation as standard. If you go to Edit Type, we'll notice that our width is 750. That's good. We'll keep it at 750 for a wall that we have, which is 300 to 400 millimeters thick. And then our foundation thickness, let's go ahead and make that 450. Why not? Just make it 450. Okay. Now, make sure that here in our structural panel, because we're going to be placing in rebar, we just want to make sure the cover is fine. So the cover here says 25 millimeters on all sides. So then go ahead and as you highlight over the walls, you notice they go blue. Let's go ahead and click on all our walls. So if we click on the back wall, you'll notice that the strip footing appears. Click on this wall, this one, this one, this one, that one, this one, this one, this one, and this one. And there we have our strip foundations. Lovely. Now, we go back into -01 FFL. You'll notice then that our foundations sit below our walls. That's nice. Let's just do the external walls for now. So we're going to 3D. There's our strip footing. What we're going to do, we're going to place in some rebar. So if we go back to our level and just select the walls for now, right click, so select one, and if you just select one wall for now, right click, select all instances visible in view, and it'll select all the same type walls. Go to the glasses, click once, just say hide element. Now this is temporary hiding it. It's not gone, it's not deleted, it's just temporary, and you know it's temporary because it's got this light blue box around it. Okay, we're going to go ahead and put in some rebar. So normally on a house you probably wouldn't put rebar. These would just probably be mass concrete foundations, which means it's all concrete to a very high spec or whatever spec the structural engineer proposes. But just for the purpose of this exercise, we're going to put in some rebar in this foundation and that foundation. Okay, the first thing we're going to do is we're going to click on this foundation, and in the mark we're going to call it strip footing 1, and on this one in the mark we're going to call it strip footing 2. The reason I've done that is because we're going to have to schedule rebar, and we want to make sure that whoever reads the schedules know what members of foundation the rebars are going into. Okay, so up here in your structure tab, you'll see reinforcement, all the rebar opportunities and stuff that you have up here. So we know our cover for the thing is 25 mil. So we click on that, it's 25. Some structural engineers might want it 50. We're going to keep it 25 for here. So I think it's probably a good idea to stop and quickly talk about foundations. The foundations that we're drawn in the model are shallow strip foundations, okay? They're for a generic scenario where the soil conditions are good, the load bearing strata is low, and I just want to touch upon when I'm banging on about the cover for the foundations, the rebar, bending codes, bending schedules, what am I on about? So let's go to the chalkboard and let's try and explain this out. So let's just put this here like that. We all see the chalkboard and when we look closer, there, let's have it there. That is lovely. Right. So let's do a quick word. If, for example, we have our foundation in sections, so that's our foundation cut in half, okay? Ground level is there, okay? That's the top is 450, okay? 450 from the ground level to here. So when I talk about cover for foundations and the rebar, I'm talking about like an invisible cover that comes 50 mil or 25 to 50 mil from the outside face of the foundation. Now this cover area is an area that shouldn't have any rebar inside it. And that's to stop corrosion for the rebar. The rebar will swell and it's to stop exploding of the concrete. And then inside the cover is where you're allowed to place your rebar. And in this cover, you will have perhaps links, like so, and straight bars that go that way. And when I talk about links and straight bars in code form, for example, if I say a 51 link or a 00 straight bar, those codes like 00 or 51, come from a specific document called the BS 8666. Now, if you download and look at the BS 8666, there is a shape assigned to the code. Okay? I know it sounds quite complicated, and it is. It's a dark art, but it is something to look at so you understand when you're on site or when you're doing a model for someone, when they talk about rebar codes and rebar bending schedules, you'll have a grasp of what they're talking about. Okay? I will go further into this one day in a different tutorial, but for now I hope this makes sense. And yeah, okay, back to the model. For the 3D, on this strip footing 1, if you select it once, right click, override graphics and view by element, surface transparency, and just make that all the way to 100. Okay. Because we want to see what rebar we're putting in there. Okay. We'll change it back afterwards. Go into 01 -01-FL, sorry. There's our strip footing. We're going to place some links. So if we click on the rebar, okay, no, that's fine. Go yes. And we're going to put in a 51. Now, if you check out this document here, this will give you all the shape codes, all the shape diameters, how to design rebar, how you should place it, the bend and moment schedules, etc. So yeah, this is how bars are categorized in codes, and I know from experience that 51 is a link. We're also going to do a straight bar, which I know is 00, but let's just click on 51, control, click on 00, so we highlight the 2, and just say open. Okay. So the first thing, we're going to put some links in. So at the moment, it says the 00 shape. So I know that's a straight bar, but we want to link 51. So click on 51. Okay. Now, notice that our placement isn't quite right. That's going to be a very large link. So if we go to the placement and we click on near cover reference, placement perpendicular to cover, then our rebar will start setting into, if you toggle around, you'll notice that it goes perpendicular to the nearest cover. But we want it there, as in the links go across, all the way across here, and in this motion. Hard to explain, but hopefully you're on the same page I am. So if we just go click, that's our bar. Okay, so if we go to 3D, you'll notice our bar sits there. Again, if you can't see it in 3D, just click on the element, the strip footing, right click, override by element, and make sure your surface transparency is all the way to 100. So bars are going to be spaced at, we'll say 200 millimeters apart, and they will go along the entire member or strip footing. So if you click on your bar, your link, and then go to the modify section up here, click the drop down box, and there's a few options. So you can go maximum spacing. My maximum spacing, which I want to set out here to be 200, and there it will put in links for the entire member, like so. Or you can do number with spacing, which is probably one I choose. What I normally do is do maximum spacing, so it gives me the number over maximum spacing of 200. And then I like to do number with spacing, just leave it like that then. Because it sort of makes it easier to schedule then. So let's go ahead and put it in this member as well. So if we click on that, right click, override graphics and view by element, surface transparency 100, okay. Go down to your floor plan. There's your floor plan. Oh, let's drop that by 1. Let's go down to your floor plan, and on this one, if you click in rebar, we know our placement's near cover, we know our placement is click it to cover, and there it is. Okay. You can also reset the rebar layout here. So if we do the single layout, say maximum spacing, there it is. And obviously change the spacing to 200. And there we have links in the two members we want links in. So now we're going to go ahead and do some straight bars. So go to Rebar. We're going to make sure our shape code is 00. If it's not, say for example you have 51, which is a link, you want 00, which is a straight bar. We're going to go place near cover reference, placement parallel to working plane because we want it on the top and the bottom. And just click it in anywhere for now, like that. Okay, and there's our straight bar. Now we wouldn't have a 30.5 straight bar. Normally, I see 8 m ones done. So if we go to so when you click on the rebar, make sure you type in the dimensions A here, 8,000 millimeters, 8 meters. Okay, and our straight bar. So go to 3D. You'll see that straight line is our straight bar in our member. Okay. Now we've got our elements in to the foundation. Let's go to FFL. What we're going to do here is if you go into View, Section, and just draw a section through this part here, double click on the arrow, you'll notice now that our rebar is showing in our foundation. Let's just reduce this a sec. So in your scope box, pull down the blue arrows, adjust the blue arrows so you have something like that, and let's just make the scale 1 to 20. Okay. And also make it fine. So we've made it fine, and now you see our rebar shape, which is the link. This is 51 link, and this is our straight bar 00. Now the link always usually has a tick in the drawings I see. So let's go ahead and you can change that by here. So let's make the stirrup tie 135. There we are. You've got a little kick. That's just to indicate that it's a link. I think it's like a generic annotation to show people, yep, that's a link or an L bar or something like that. Okay. And this is our straight bar. 8 meters. Now notice it's quite small black dot. That's because we've defined its diameter. Now you can change the diameter here. H is the code for diameter. I think also you can use B, but we're going to go ahead and make it a big chunky one for you to see. So let's make it H12. That is 12 in diameter. And then you got H32, H16. Let's go ahead and make it H12. Let's move this bar to the corner of the link, and let's specify maximum spacing, and it has the maximum spacing for the cover of 4. Go back to 3D. You'll see there is our straight bars. Back to our thing. If you click on one of the dots, click on this mirror tool, highlight at the bottom of the foundation, see the purple triangle, click it once, drag down, click it again, and it will duplicate straight bars on the other side. And there we have our straight bars with our links, looking like a bit of a cage. And in normal circumstances as well, you would have L bars on the corners, and these straight bars would be multiplied across the member with some laps in between. But I'll go into that in more depth tutorial on rebar and rebar scheduling and touching on rebar scheduling. I'm just going to quickly show you how that looks. So if we go into View, Schedules, schedule quantities. Yeah, save the project. If it prompts you, anytime save the project. And then in this new schedule dialog box, go down until you see rebar A, B, C, D, E, F, G. There we are. Ah. We want, oh, no, sorry. Go down to see structural rebar. That's the one you want. Okay. And in this, we're going to put the bar mark, which I think is the rebar number. Click it once and click the green arrow to make it go across. We want the host mark, which is our strip footing, which should be called member. We want the rebar shape code, so it'll be say 00 or 51. We want the bar length. We also want the diameter, so we'll usually have A, B, C, and D. And then, just for the purpose of this tutorial, we'll also have, let's say, quantity. And we'd also have total bar length at the end. Actually, let's move that total bar length at 1 by using these arrows at the bottom, and we'll quantity at the bottom. Just select OK for now. And there is our rebar bar bending schedule. So it gives us the rebar number. If this happens with 3, 1, 2, 4, okay, what we want to do is go into sorting and grouping, edit, sort by, rebar number, ascending. Okay. And there you are. It's a bit neater now. So our rebar number 1, which is in strip footing 2, shape code 51, so there's a link, total bar length, so that is there, and then it gives you the diameters, and total bar length for the entire count of 30 is going to be 73111. Rebar shape 1. Okay, so if you come across something like this, if you just click on it, say highlighting model, it will show you the bar it's on about, which is this. Bar shape isn't called rebar shape 1, so just go in the drop down menu, and we know it's a link, so just click on 51. So when we go back into our rebar schedule, it's now changed to 51, which is good. And it's changed the rebar number as well. It's going to group them. And there we have it. That's the basic principles of rebarring and scheduling.